Welcome back to another video on double A learning. Today we are doing another math topic, and real quick before I start this video, if you guys have any other suggestions besides math, I can do English, science, history, whatever you guys want. Just leave them in the comment section below and I'll try to answer them as quick as possible. But today we're going to focus on Math World, and we're going to be reviewing a key concept in math of trigonometry. So just before I get into this video, this is going to be a more foundational version of trigonometry. We won't go advanced in like the derivative aspect of trigonometry or the integral aspect, or not even like the trig identities. Rather, I just want to stick to the right angle triangles and the trig relations, as well as the special cases of the 45, 45, 90 and the 30, 60, 90 triangles. Okay, so let's get into that. So trig. So when you first learn trig, is usually in geometry, and you'll probably have heard the terms sine, cosine, and tangent. These are going to be really key in this trig world. So their relations to a right triangle are also really important as you advance in math. So just as a quick refresher, so we know what a right triangle is. A right triangle is like this shape, and it forms a right angle right here, along with these two sides, and all the sides add up to a total of 180 degrees. So I want you guys to know this quick mnemonic before I even talk about anything about sine, cosine, and tangent. It's called so, ka, to, toa. Yeah. So what this stands for, so the S here in so is sine, the O stands for opposite, and the H stands for hypotenuse. Now what does this look like when we're looking at a right triangle? So just for the sine, we're just taking the sine in this case. Let's say this is the angle we're focusing on. So if we want to find the opposite of this angle, what would that be? Well, it'd be this side right here. The opposite of this angle is this side. We'll just label it x for now. It can be any variable, but I just chose x. Now, in a right triangle, this side right here, that's always going to be the hypotenuse. The hypotenuse is always the longest side in the right triangle. So we'll label that as y in this case. So sine will have this relation where sine is equal to opposite over the hypotenuse. You can remember this, the so, because the O comes first, then the O go on top, and H comes next, then the H go on the bottom. So in this case, in the mini diagram I drew, it would be sine is equal to x over y. Now let's move on to the ka of SOHCAHTOA. So let's draw the sketch again of the right triangle. Again, this is the right angle, and let's make this the angle here. We're focusing on this angle right here. So now we need to find the side that's adjacent to this angle right here. Now we know this side is opposite from our last diagram, and we know this side is the hypotenuse. So that means this side right here has to be adjacent. We'll just label it A. Again, we know what the hypotenuse is. We identified that as y. So, using the same basis here, we know that cosine would be equal to the A value, because adjacent comes first, over the hypotenuse, h. So when we focus on our diagram, it would be cosine is equal to A over y. Again, these are just variables. You can name it anything, but I just named it A and y. Now, moving on to TOA. This one, let's draw a diagram again. A right triangle, of course. Let's focus on this angle once more. Now we need to find the opposite side, which we already know. We label as x, so we can write that as x. And we need to find the adjacent side, which we had labeled as a. So now we know that tangent is equal to the opposite, because O is first, over the adjacent, because A is next. In this diagram, that'll give us tangent is equal to the x value, x, over the A. So that's the foundations of basic trig functions that you need to know for right triangles. Now, I want to show you guys the special case before we go into any examples, because we'll be using them. So, the special case, the first one, is the 30, 60, 90 triangle. Again, this is, once more, a right triangle, nothing different there. This right angles are always 90-degree angles, so that checks off this area. Now, in a 30, 60, 90 triangle, either of these sides can be 30 or 60, but one must be 30 and one must be 60. For this case, I would make this 30 and this one 60. But it doesn't matter, you could have flip-flopped those. Okay, here's the relations you guys have to remember for this course. So, in a 30, 60, 90 triangle, the hypotenuse is always equal to the length of 2. The 90 degrees always points to a 2. Next, the 60 degrees always points to a square root of 3. And then the 30 degrees always points to a 1. A way I like to remember this is that 90 is seen as the bigger angle between these, and 2 is a bigger number compared to the square root of 3 and 1. And then the next largest angle would be 60 degrees, and the next largest side is the square root of 3. And then the smallest angle is 30 degrees, and the smallest side is 1. So that's one of the special cases you have to know. The next special case you have to know would be the 45, 45, 90 triangle. Again, the right angle is there, so that checks off the 90. Now these two are both going to be 45-degree angles. And we can see in both of these, if you were to add 30 plus 60 plus 90, you'll get 180. And a right triangle, the sides always add up to 180. Once more, 45 plus 90 is again 180. So that fits the criteria too. So for this one, you have the 90 degree always faces a root 2. And the 45 degree sides always have a 1 and a 1. Again, a way I like to remember it is 90 is the bigger angle, and then the side of square root of 2 is the bigger side. And then 45, 45, 1, 1, small, both small. So you have to remember these two by like heart for all of your like next math classes that you might be taking in the future, or for your geometry course or trigonometry course you are taking. Okay, now let's get to some examples. I'll make sure to include this in the side, just so you guys have a quick memory in case when we're doing the examples, but I'm going to create a new slide now. Okay, so my first question for you guys would be, we have an angle of 30 degrees, a hypotenuse of 10 centimeters. Our goal, find the opposite side of the 30 degrees. Okay, now I'm going to draw the relations again of 30, 60, 90, and the 45, 45, 90. Again, in this video, you'll have the reference, but I want you guys to have this memorized for your next test, upcoming quiz. It's going to be important. That's the 30, 60, 90 as we reviewed, and now the 45, 45, 90. Would be that. Okay, going into this question. So let's just draw a diagram so we have a better understanding. So we know all these questions are going to be right angle triangle based. So let's just sketch a right triangle. Sorry for the bad drawing. Okay, we know there's an angle of 30. So we already know that this right here is a 90-degree angle because it's a right triangle. Now that 30 degrees, we can put anywhere. We can put it right here or right there. For drawing's sake, I'll just put it right here. Make sure you label it 30 degrees. And we know the hypotenuse is 10 centimeters. That's important. So let's label the hypotenuse as 10. Okay. Our goal, find the opposite side of the 30 degrees. Well, we know sine. We remember our mnemonic. So, ka, toa. From just SOHCAHTOA, we can see we're given the hypotenuse. So which one has the hypotenuse? This one has the hypotenuse. This one has the hypotenuse. So that means we're not using tangent in this case. Next, what are we tasked to find? We're tasked to find the opposite side of the 30 degrees. The opposite of 30 degrees, well, we know that's right here, this side right here. So doesn't that seem very familiar? It seems like the sine function. We'll just label this x because we don't know what it is. So we have to find the opposite, but we're given the hypotenuse. That checks off the sine and not the cosine. So let's use the sine function. So we have to find sine of 30 degrees is equal to the opposite, because O goes first, over the hypotenuse, the h. Okay, now you guys might be confused. How do we get sine of 30 degrees? That's where we use these special triangles. In order to use these triangles, we have to do the same thing we're doing here, but we're given the numbers here. So sine of 30 degrees. 30 degrees is right here. We know that. So sine is opposite, the ones right here, and the hypotenuse, 2. So we can tell the sine of 30 degrees is simply equal to 1/2. So all we can write is 1/2 is equal to x over 10. Again, I can say that once more. The 30 degrees, we can just, sine of 30 degrees, we can simply find by using our 30, 60, 90 triangle. We see 30 degrees matches here and 30 degrees matches here. All we have to do is use a special right triangle that we know of and do opposite, which we know is 1 because we have this memorized, and then the hypotenuse, 2. So that's simply 1/2, O over H. Now we know that's equal to x over 10. Multiply the 10 to this side. That will be x is equal to 5. We're not done yet though. We need to make sure we include the centimeters. So x is equal to 5 centimeters would be the answer to this question. Okay, that was an easy example. Let's move on to a slightly more harder medium example. I'll be creating another new document for this. Okay, this question is going to be, we know the opposite, this is going to be all right triangles again. Opposite side is equal to 7 centimeters. And we know the adjacent side is equal to 24 centimeters. What is the hypotenuse. Okay. For this question, you actually don't even need to use trigonometry. You guys need to know this theorem right here. A squared plus b squared equals c squared. This is known as the Pythagorean theorem. You guys probably already learned it if you're taking a geometry class or any higher level math. But this is going to be very important to solve the question right here. So, we have a right triangle. Again, right triangle is implied. And we know the opposite side and the adjacent side. But we don't know the hypotenuse. So, in this Pythagorean theorem, these two sides, the A and the B, or this side right here, doesn't matter what you write it as, A or B. I could simply have flip-flopped these. But the C is always going to be the hypotenuse. Again, C is just a variable. I can make that variable whatever I want. I can make it Y, I can make it X, but whatever this value is right here is going to be the hypotenuse. So, we know the opposite side is 7. We'll just say B is 7 because we're not solving for any angle. We don't know the angle. We just need to find the hypotenuse. And we know the adjacent side is 24. What's the hypotenuse? We simply just plug it into this formula. So the A value we know is 24. So 24 squared plus 7 squared is equal to c squared. Now, simply simplify. So this would be 576 plus 49 is equal to c squared. Adding those together, you get 625 is equal to c squared. And you can find that c is equal to 25. Again, don't forget the centimeters. It's mentioned in the problem, so mention it in your final answer as well. Okay, moving on to our final example, which I would consider more challenging compared to the ones we have done, or around the same difficulty, depending on how comfortable you are with this topic. Okay, so the question is, one side equals 60 degrees. Side adjacent to 60 degrees is 6 centimeters. What is the hypotenuse? Okay, for this one, we will need our special right triangles. So I'm just going to once again write it down. 30, 60, 90. Make sure you guys have these memorized. Once again, I'll keep repeating this. This would be the 2, and I'll label this the 30, and this one the 60. This one would be root 3 then, and this would be 1. And now the 45, 45, 90. I'll write this down, but simply just by looking at the problem, we know it's a right angle triangle problem, and we see there's a 60 degrees. We really wouldn't need the 45, 45, 90 formula, but I'll just write it down just so you guys are aware of what it is once again. So we know this is 90, this is 45, and this is 45. Sorry for the handwriting. This would be 1 and 1. Okay, so let's just draw a sketch again. We know it's a right triangle. That is really bad. That's a little bit better. Okay, so one side is 60 degrees. We don't know what that one side is. I'll just label this the 60 degree side, just because. We know this is 90 at least. By process of elimination, that leaves this is 30. Okay, and we know the side adjacent to the 60 degrees is 6 centimeters. So the side adjacent, let's see, go back to our SOHCAHTOA. SOHCAHTOA. Okay, we need to find adjacent. So which one has an adjacent? Sine doesn't have an adjacent. There's a adjacent in cosine and adjacent in tangent. So we'll keep those for now. We need to find the hypotenuse. So we know this is adjacent right here because the 60 degrees are right here. This would be the opposite. This would be the hypotenuse. This would leave the adjacent. So this would be 6. We need to find the hypotenuse. I'll just label this as x. So which one has hypotenuse included as well? Well, that's cosine. So that checks that, and that crosses out the tangent. So we know that cosine is equal to adjacent over hypotenuse. So given this information, we can just plug and chug. So cosine of 60 degrees is equal to adjacent, the 6 right here, over the hypotenuse, the x. Alright, now we need to solve for cosine of 60 degrees. Let's go back right here. So we see a 60 degrees right here. So what can we tell? The opposite of that would be the root 3. So we're not looking for the opposite. So that's not right. So we're looking for the adjacent. We know the 2 is the hypotenuse. So the 2 would go in the bottom. And then the top would be the 1. Because that's what's adjacent to this angle. So cosine of 60 degrees is 1/2. So 1/2 is equal to 6 over x. Now we need to solve for x. What do? We can just simply do simple algebra. We know that 1/2 is equal to 6 over what? So if we know 6 over 12, we can simplify that into 1/2 by dividing by 6 here and dividing by 6 here. That'll get you 1/2. So the x value would equal 12. But we're not done. The centimeters is still there. So the answer would be that x value, or the hypotenuse, is equal to 12 centimeters. Okay, I hope this video was helpful for anyone who is struggling with the trig foundations. I have a practice link I'll put in the comments or in the description, but make sure to review it if you guys are still confused. Thank you so much.